This episode of Dirt Time is brought to you by Top Spray. Top Spray manufactures and installs environmentally responsible erosion and sediment control solutions. Go to topspray.com for more information. And the Rifle M100. Your work just got a lot easier with the Rifle M100 staple gun. With its 100 staple cartridge capacity, ergonomic design, the Rifle M100 will save you time while saving your back. Reliable, precise. The Rifle M100. Visit riflem100.com to learn more. The Rifle M100 is a product of erosioncontrolblanket.com.
On this site here, we're going to do the VMSE, Vegetated Mechanically Stabilized Earth. What that requires is you to cut a terrace just like you would with brush layering. We cut the terrace, we're going to put some branches down in contact with the soil first. Then we're going to lay the coir mat out over the top of the branches with the end of the coir mat flopping out over towards the creek. Then Dale's going to put about 16 inches of soil lift in there, compact it a little bit, and we're going to try to pull the fabric around and wrap the face of that soil lift. The challenge is going to be then getting that face nice and smooth, and because it's going to show any irregularities when you have that carpet up. And then once that soil wrap is done, we're going to do another brush layering, followed by another soil wrap, and wrapped around again. So that's the plan for this site, the VMSE. Let's go grab a couple of bundles over there that are soaking. On this first layer, I'd like to put down about 6 branches per meter is all. And then we're gonna put the fabric down on top of that. Then Dale's gonna put a soil lift, and then we're gonna wrap the fabric around. Then we're gonna do our next brush layer. In here, we're gonna go a little bit lighter. We're gonna do like 3 to 6 branches per meter in here, because we're going to put the fabric down and then we're going to double it up on the next lift. We're running a little low on our willow that is soaked, and I don't want to put it as heavy in here. Plus, when you're using the geotextile, the fabric, you don't need as much reinforcement from the actual branches. Every one of these branches is going to grow. How many more willows do you need? You know, you need one willow to grow every meter or so.
Let's hold on to the 10-day soak now.
Let's grab the fabric rolls and roll them so that about 2 feet is right here, right along here where this soil is the new edge. Run the fabric out 2 feet, and then the rest of it flopped out over there. Okay, we gotta come my way more. Now we just roll this puppy out.
Ready for that first picture of the guy going now? Yeah, that's what we're talking about.
5 feet left?
Yeah.
Yeah, this one, we want this one on top of this one.
Yeah, you're right. When you flip it over, you're going to have the wrong lap if you put that one underneath.
Okay, we want this one on. Yeah, this one rolled out all the way and this one on top.
Well, you might.
Oh, good. Now you can't see the rock underneath. Watch that turtle catch the penguin.
I knew that. I got something here.
Yeah, that'll work.
Perfect. The reason you would choose a VMSE is if you get additional geotechnical benefits, just like from the brush layering, but it allows you also to wrap, as you wrap the face between the brush layering, the fabric gives you erosion control. And then not only that, when you build your slopes really steep, like at a 1-to-1 angle, you know that soil's not going to stand. It needs reinforcement. So in that case, when you have a steep slope, use your brush layering and your soil wrap. So it makes a very strong, strong slope. What Dale's doing now is he's putting a soil lift in there. He's probably going to build it up about 18 inches and tamp it down. We want about a 16-inch lift. The trick is going to be to figure out how to get the face of that lift, that soil smooth, so when we bring the fabric around, it'll look nice and smooth and uniform. And it's always a problem to do. The willow sticks through, the fabric gets caught up, so there's going to be a little anxiety here. Ideally, I'd like to start from this end, because then when we fold this one over, we have our joint right there. When we fold this one over, and then we can go back and start folding that side over. So when we fold, we're going to fold from the opposite direction, from downstream, working upstream. So it's going to take a little bit for him to get that filled. It's all hoe work at this point. We need to get this, we need to really be able to pull this up. We might need, see this is more than a beer belly. This is a lot of, I like those kind of beer bellies that are rather firm, you know. This is like a little flabby. One of the ways we've done it before is you pull on the fabric and then you get like a tamper or even a sledgehammer and you start pounding this soil back up and get it as tight as you can. Shall we see if we can get the hoe to pull on it? One thing you can do when you're compacting the face is compact this way. Okay, well I'll tell you what, let's do this right now. Let's go ahead and stake these like we're doing really good. Then you come back along and knock this kind of, well, don't push out too far. Maybe down and out a little bit. And let's get that guy to stand up and let's give that a try. What I'd like to have is more of a 1-to-1 face on this coir. Instead, we've got this thing kind of sloping back like that. Not quite sure how to fix this. What we are going to try to do, we have the stake there in the back. We're going to come back in with the hoe and push down on this high spot here and try to force this material out here. So we'll see how that experiment works. By applying force here, down and out, can we in fact build this up?
Yeah.
Kind of skeptical, but we'll give it a try. Looks like it's working. Yeah, we're putting some stakes in about every 6 feet, just kind of to hold the blanket back. A lot of times you don't need to really stake it, a few minor stakes in the back, just to hold it until the next lift goes down. Well, willow is I'm just trying to demonstrate this, another opportunity to use the willow for stakes. I'm anticipating that the next wrap is going to come down and start right here. So the next wrap can fit up against the willow. So I kind of put it where I anticipated the next wrap to be. Well, I'm still not convinced this is the best way to do this. It wasn't the most efficient. I think it's going to be okay. There's a little bit of looseness here. Probably would not be acceptable if we were in a faster stream situation, because water can get in, get this fabric moving like this, and then pretty soon you lose your the fines behind it, and there can be quite a few problems. But because we're using this with the rock veins and we're out of bank full discharge well above it, it's going to be just fine. Next time we lift it, we'll have an opportunity to try a slightly different technique, I think. So now we're going to take and do brush layering on here. We're going to put in about 10 branches per meter, okay, on this brush layering. So we're going to need to get some fertilizer and mycorrhizae down here. Sprinkling of soil, a little bit of water, fertilizer, mycorrhizae, and we'll start our new roll. Okay, we can roll netting down.
About 2 meters or so.
Stretch it out, you might make it.
One of the attendees came up with a really good idea. What if we put our lift down and didn't compact it until we had done the wrap? And then we can anticipate, maybe build it up a little bit higher. The operator can build up a little bit higher, then we'll bring our wrap around and then he can compact it down and that'll force the soil into the face. So we're gonna give that a try. I think it's a good idea. I think it's worth trying. So while we're waiting for some more soil, we'll start wrapping at least this half of it over. Gonna get the rock out of the way, the big rock that's gonna be in the way, and allow us to fold it kind of nice maybe. So we'll work from here on over. If we get it as tight as we possibly can and stake it, then he'll come back with a bucket and push down on this and force it into that beer belly deal, okay? So let's get some stakes, sledgehammers. About every 2 feet, stick in a stake. Okay, let's put a stake in here.
Think he's gonna hit you?
One more? On the bus and everybody's still working. Yeah, that's cool. Gotta love it. You know, there's some enthusiasm here. So we'll get these stakes in, and then we'll just let the excavator operator come through here and try to tuck this thing in and get it as tight as we possibly can. Well, we're gonna have Dale right now finish this side up. He's kind of heeling it in. We're trying that new technique of compressing it to see if we get a nice smoother wrap, and it's looking pretty good. Tomorrow we're going to decide whether we do another brush layer in here or whether we just lay soil up to the roadway and call it done. But for today, boy, we've done a great job. That's looking really good. In fact, let's go over and take a look and see how firm that is. Dale, come on down for a second. It's looking a lot better. So we got a nice angle, but there's still a lot of looseness. And I don't know if we can do any better with this kind of soil. Maybe what you should do is go ahead and hammer it a few more times. Okay. Right here.
That's your bucket right on the top.
But we want to keep this steep as possible. Okay. And so a few jostles in here might bring some of that material back out. Sure. Let's just give it an encouragement to settle. Okay. Okay. We'll see you tomorrow. Okay. All right. We'll be back tomorrow.
Tim Hortons.
What a day. I'm pooped. It'd be nice to just go back to the training center and just relax for a little bit, kick back. I've had to been talking and thinking, and I can't talk and think for 8 hours straight, so I'm burnt out. Looking forward to getting on the bus. Morning, everybody. Boy, another beautiful day, huh? The focus of today's work is going to be to, well, we'll walk over together and check out and see how the soil wrap went. We're going to do brush mattresses. And the next site over, we're going to do vegetated riprap, which I know you've all been excited to do. So those are kind of the three main activities. I'm hoping that's what we get to experience. I hope the weather stays like this. Anybody have any ideas how we could do this better? Maybe water it in a little bit and knuckle it in some more. I think this soil's so heavy though, it's not gonna move much more, and then there's the risk of turbidity. A willow wattle in front, that would be good too. What about some of those straw rolls or fiber rolls? What about the compost berm? You know, we lay a compost Filtrex sock in the front of it and roll it over, yeah? This is like the 6th one of these that I've built, and I've had trouble every time getting the face the way I wanted it. And I think I'm gonna go to putting some kind of something, a log, a biolog, or something in the front of them to roll around, just so we get that nice face. So, every bit of that coir netting that goes into the bank provides geotechnical stability, as do the branches. The branches back there as brush layering also provide some kind of drainage to reduce some of the pore pressure building up in your slopes. Looks like going to be another nice day. We're just getting started. We've got to get our vane built. Dale is building the last of the vane. We made friends with him and brought him a cup of coffee from Tim Hortons in town, and he's raring to go. So he's started on the vane. Got our live siltation done. I got to run over here and talk to the operator and make sure we've got our slope laid back right for our vegetated riprap, and then we're going to do our brush mattress and some erosion control today, and we're hoping that'll do it. Let's see how it goes today. This is the beauty of these rock veins. You know, you can place the rock right on the stream bottom while they're flowing. He's placing some individual stones. I really like the idea of using the self-launching stone also. Self-launching stone, we built this LPSTP here, and we had specified self-launching stone. And even though this stone is graded, it's graded from a large 2-foot diameter stone down to about a 1-foot diameter. So it's got a gradation from 1 foot to 2 foot. That's not what we mean by self-launching. Self-launching, if we wanted a 2-foot stone, we would go 2-foot stone. 95% of our rock would be less than 2 feet. And it would grade down in such a way that maybe 95% of our rock would be larger than 3, 4, 5 inches. So we would have that full gradation between. Now, the reason it's called self-launching stone is if you have a lot of those little stones and big stones, you can stack them up relatively steep. And if the stream comes in and scours a hole, the stones actually fall into the scour hole. Maybe a big rock, maybe a little rock. They fall into the scour pool, the next rock falls in, next size, and pretty soon they've locked themselves together. By using self-launching stone, you don't have to go in and dig keyways and stuff into the bed, which would be impossible in a salmonid stream like this in the wintertime. Another tremendous benefit to self-launching stone, it's also known as self-filtering stone. So when you lay your stone toes along the river, those gradations provide this filtering so we don't lose fines from the embankment through the stone and into the river. So that will decrease your turbidity or any erosion. It'll also decrease the likelihood of losing your material from the banks in there and having bank failure. So that's kind of the key of this entire training and activity that we see here, is the use of rock and these kind of rock and willow in these rather unique ways. Dale's a very good operator. That's a good vein. interesting thing when you're looking at rivers and streams. You can see up there around vein 1 and now at vein 2 is the bubble line that comes down the channel. Now that bubble line or the debris line or the trash line in rivers, riverboat captains have been using those for a long time to indicate directly below them is the deepest part of the river. That's where the thalwag is. So with these redirective methods, what we're actually doing is you can physically see us moving the curtain over. So let's watch that bubble line shift over as this vein is being built. That should be interesting. We're gonna go over and see if the mattress site is ready yet. I got people standing around, you know, they're looking for things to do. The equipment operators can't keep up with this. That's gonna work all right, yeah. Brush mattress is actually a mattress of willow that lays on the slope. Again, the basal ends are down in the water. They're rather long, thick mattress of branches that go all the way up the bank. Now those branches, in order for them to grow, they have to have good contact with soil. So we also put stakes in and wrap twine around it, and then we torque them down in against the soil. Then it's a good thing to sprinkle some soil back over the willows so they have an opportunity to sprout and root and stuff. It was documented that a willow mattress could withstand 7 meters per second. That's 21 feet per second velocities, which is phenomenal. So we're gonna put in the most durable, strongest willow array that there is. Okay, the slope's ready now. We can go over there and do brush mattressing. We can do brush mattressing now. The slope's ready, yeah. The excavator operator keyed it down. We've got some nice water down at the toe down there because you want to keep their feet wet. Hey, we need to make sure we save about 100 for the riprap. We're just going to lay a complete mattress along here. We want it about 3 to 6 inches thick. Just cover it with willow. Their butt ends down and their little heads poking up. Just to the willow tree right there, that little willow tree. So what we're trying to get is about a mattress that's about 3 to 6 inches thick. That's looking like it comes out to about 40 to 50 willow branches per meter. It's quite a bit higher than we've ever used before, and it'll eat up the willow. But then if this technique is anchored right and stuff, also that it really is worthwhile in stopping erosion. You can use this instead of riprap if all conditions are right. Use a rock toe, of course. We always want a rock toe, but this is another way of stabilizing banks, a truly green way against high velocities. So this is looking pretty good. We're a few more little thin spots. So we got the mattress down. The next step is to get the stakes in. Okay. The thing we're going to do with these stakes now is we stake them through the willow mattress. We put them about every 2 foot on center, diamond shape. Then we start our rope and we tie our rope between each stake. And then we cinch these guys down, and the rope and these stakes pull everything down into place. Let's see one of those saws. One of the things that we need to do is we need to put a notch in these stakes. We get our rope as tight as we can, and then we come along with a sledgehammer and we torque these down. That's why these construction stakes are so effective. You drive those into the ground and they won't pull back out. And all the time that they're being driven in, they're pulling the material with them. These are a 2x4 construction stake cut on diagonal. Now you don't want to take off too much wood because you're going to weaken it. So about like that, so we can make sure we hook the rope in. it might behoove you to put another notch over around on the edges, okay? So we're going to need some of these guys notched up. On this particular, since our willows and our bank isn't too tall, we basically need you know, 2 rows of stakes with another row in the center of those staggered, and I think that's going to give us enough strength. The deal is be able to torque this guy down. It's a little difficult to drive these in. The notches are up here. The stakes are a little punky. They're kind of working without the notches. That's sliding a little bit though. Sometimes it's easier to put it in smaller sections of rope. So if you can't get the torquing you need, you can stop your rope tying, like cinch this part down, maybe make some adjustments. This notch here should have been lower, but you don't want to have to make a notch in them so big that the notch weakens the wood. We didn't have the best stakes in the world. Rope's a little bit too big. What we're going to try next is cutting the stakes just slightly a little bit smaller and just tying the rope around the stake and not using the notches. And we'll see if that works a little better. Well, this passes inspection. It looks pretty good. Looks like they used the double clover hitch and we're able to anchor these down pretty good. So next step is we're going to have the excavator operator come down here and sprinkle some soil in. You don't want to bury the willows too much up in there. That's where they're going to be sprouting. I thought while we have our compost blower, it'd be nice to actually put a little compost in here too. You don't want to leave the willow branches sitting out in the sun or out in the weather so they dry out. So we'll cover them with a little bit of soil, a little bit of compost, and come next spring, it's going to be a full-on mattress. Okay, you want to put a little soil down on there. Here's the rock, and here's the willows coming down. Put a little soil down in here. Half of the willow branch, we don't want more than a couple inches of soil. We kind of, you know, down at that lower part, they can be buried a little bit deeper. I guess you can spray, go ahead and spray a little bit on here too if you want. We got the compost blower. We're gonna cover the brush mattress a little bit with some compost. That ought to be dynamite. That's some of the secret sauce that'll help this to grow. Put a little compost on this bare soil for erosion control. Boy, we're just about done here. So Ray, what are you doing here?
Well, what we're doing here is we're monitoring specifically the sediment. We measure it in terms of turbidity and suspended sediment. We're also measuring some settled sediment with these special trays we have. So what we typically do is we take some measurements upstream of the work site and downstream of the work site. You measure the water turbidity? We grab a water sample like this. That's a grab sampler there? Grab sampler. And we take this and we just fill it up. We put it into the water, whatever distance we want. We want to make sure we don't contaminate the water. We take this water sample back to our, just right here on site, and we have a turbidity meter. Your mobile laboratory, huh? Yeah, the mobile laboratory. And so we measure NTUs, or nephometic turbidity units, just to measure, and we have a certain number that we can go over a certain period. How many are you allowing them here? We're allowing only 8 units over. Right now we're talking 3.9, 4.0 upstream. And the highest reading we had with some actual construction on the bank was only at a level of about 21.
Wow.
For a short period of time.
So when people are thinking about construction in the Canadian streams and they set up a monitoring plan, this is what they're talking about, huh?
This is one of the special types of monitoring plans that is absolutely, I consider, essential. And it benefits everyone, the regulator, the citizens, the owner, and especially the fish.
All right. All right, all you need to know about turbidity. Vegetated riprap time. Just how much, if you weren't putting willow in, how long would it take you to just riprap that? Dale wants to start down in this first half here. So we can lay some willow down starting right about here. We'll break some of the bundles up. We want to lay a big willow branch down about every foot or so. Let's see how that goes. We got, I think we got more than enough willow here, don't we? Okay, so what we're doing now is vegetated riprap, and basically what that is the easiest way is the bent pole method. You lay your slope back the natural way you would before you lay riprap. You lay a couple of stones down at the toe usually, and you just lay your willow poles on the bank with their heads coming up. The operator then will continue to lay riprap like they usually do, and periodically they'll bend one of the willow branches up and place more rock. So when you're all done, you'll have a riprap wall with periodically willows sticking up through the rock. What you can't see is underneath the rock, the entire stem is in contact with the soil in a growth medium and it's ready to grow. So that's what we're going to do here. The first step is to lay a willow branch about every foot apart, because if we had one popping up every foot would be plenty. Once we get the willow branches, Dale's going to start laying his riprap in a traditional manner. Periodically he'll stop and let us pull one up and he'll place a rock behind it. So that's kind of the plan of action here. One of the other techniques that we have is the bundle method. So if you don't like doing the bent pole method, lay the poles down, you can just cut a little notch in the bank and you could just lay the whole bundle down in there. And then as the rock gets up there, you can untie the rope and start pulling a piece up and bending it up. So let's try a couple of those while we're at it. Here's the bundle method. We'll leave this one right down there. Just leave it like that. Let's take the rest of this little willow and lay it up as a live siltation right there where we have the rock, and take the rest of the willow and do a live siltation right in there at the toe. Watch your head. Watch your ankle. I think it's better just a couple of us here. I got it. I got it. What we're doing here is the bent pole method, vegetated riprap, bent pole method. So the poles are laying back in here. He's very carefully laying some rock down as we're bending the poles over. Hey, hang on just a second. Hey, wait a minute. Don't bend them all back. Put some of those back. We're just gonna bend one or two at a time, and then very carefully as he lays the rock down. Then when he gets away, then you roll him down by hand. All right? I don't want you too close to that bucket. I'd rather have just one guy, one person working near the bucket. Okay. By hand. Wait, don't cut them until you've bent completely, until you're sure you have them bent up. Then cut them. We're gonna start, it's getting on 4 o'clock. We're gonna start meandering on back and meet over there by the VMSE. Well, that does it for this episode of Dirt Time. You know, we got really a lot accomplished last couple of days. I've learned a lot. I hope you learned a lot. We now understand really well how to build veins and redirective methods. We know how to cut willows and plant the willows in various bioengineering arrays. It's been really an exciting project. Frankly, I'm glad it's done. I'm a little bit tired and looking forward to seeing you in the next episode of Dirt Time. See you later.